This is Chet Udell, and I'm going to talk to you a little bit about just using the eMersion twist. And the twist, again, is this little thing that is, it has no plug-in ports. Again, this is going to look different from yours because this is the old beta prototype with, instead of charging pegs, you're going to have a USB port. And you're going to have nice enclosures. The buttons are going to be in the exact same place, except that the long one on the bottom here is your on and off, so just the same exact thing, turning this on and off. And the top button, again, is just a review to synchronize your eMote with your particular fuse. So let's go ahead and turn this off by pressing the bottom button. And then, next thing is we should go ahead and let's go ahead and turn on the eMotion Digital Data Workstation, and let's go all about the eMotion twist. So I'm going to open that up. Motion Digital Data Workstation. Okay. The next thing is you'll want to turn on your fuse. Make sure you have that serial device properly selected. And the twist module is going to pop up. Now what you should do is let's go ahead and place your twist on a flat surface. So just straight down so that it doesn't matter where it's facing, it just needs to be perfectly level. And then you're going to double click on the module if you haven't already done so to open up this window. Press the calibrate button. And now what this is going to do is it takes all of the gyro biases, it takes where you're at on the Earth's magnetic field and latitudes, because your magnetometer data here is going to behave differently based on whether you're far north or far south or on the equator. It's all really kind of crazy. So this calibration routine gets rid of all of that. Now that you're at 100%, and feel free to press this button anytime you feel like the data just isn't making much sense. But now that it's calibrated, notice that when I move side to side here, this is like the airplane's what we call orientation or heading. This is an airplane's, and I tilt the nose up and down. This is an airplane's pitch. And then as if the airplane's wings were rolling up and down or rolling from rocking side to side. That is what we call the roll, and that is the x-axis. And I want you to notice how the x movements correspond to the gyroscope here. And the gyroscope basically measures inertia. And that, for the eMersion hardware, is in degrees per second. So notice how when I'm staying still, I'm moving close to 0 degrees per second. But if I rock the x-axis, notice how I get peaks based on the direction, because that is the sort of the inertial movement there. The y-axis, same. Moving my nose up and down, I get motion on that axis. I also get that on the accelerometer. Notice how the data on the gyro is different, because if I hold still for the gyroscope, it goes to 0, but it's at -1g here. If I point straight down, it stays there. So the gyroscope only moves, the data only moves if you're moving, which is kind of nice. The accelerometer sort of keeps track of Earth's gravity on any given axis. And so the z, this is sort of different between the gyroscope and the accelerometer. The gyroscope will give you the rocking motion back and forth, but for the accelerometer z-axis, that's the gravity force going straight down. And so as you can see, I have 1g of gravity here. If I turn on my side, I have 0 g's, and if I turn upside down, I have -1g. So 1g, 0g, -1g. And then my magnetometer basically will give me my heading on Earth's magnetic field. And this data is pretty, I mean, that's really fun to play with too. So just kind of check it out. This one is also useful, the setting of your origin. So let's say stage front, go ahead and put your accelerometer down, click this button to set your origin. I like to use AutoCal enable, and notice how it snapped me to the very front. And now it's going to keep track of where I am, sort of based on the original direction, original origin of my position on the stage. And that's kind of nice. And the reason why occasionally the thing turns green versus blue is it's green when I'm holding flat, and then when I sweep across that point of origin is when it like recalibrates my heading on the stage. So you can feel free to use that or not, depending on your application. The next thing is the Euler angles. And so you'll notice on your digital data workstation, if I were to create a track, I'm just going to go ahead and create a track now. So it says wait, and then I'll wait for it to say ready. Okay. I'm going to select my twist. I'm going to go to Euler X. And the Euler axes are basically, this is rotation. And I want you to notice if I turn all the way on one side, I get 90 degrees, all the way up to 180, and then negative 180, all the way back to 0, right? And this is kind of fun to play with. But you're not actually going to get 90, 180, 0. You're actually going to get range between -1 and +1 based on a sort of a sine or cosine function. And so you can swap the phase. So let's say when I'm straight up, maybe I want my phase to be in the middle. And when I lean to one side, I want it to approach 1. When I lean to the other side, I want it to approach -1. Or maybe I can invert it. Now when I lean to that side versus the other, the data is inverted. So I can swap the phase, I can swap the inversion of that data, and all of that is pretty fun and useful to play with. The y-axis is, again, you guessed it, straight up and down. And again, like if I'm flat and I change it to sine, now I can have the data go up when I want it to and down when I'm approaching down. And that's pretty useful. And z, this also is a very useful thing. So when I'm in the center, I read 0. When I go off to the right, I read negative values. When I go off to the left, it reads positive values. Or I can invert that, right? Now it's negative on that side and positive on the other. Or I can change the phase. And, you know, all this is very useful depending on, you know, what it is you want to do. All right. And so that's basically, oh, here's another thing. Maybe you can't mount this on your, I play a brass instrument, so this can mount really well on a brass instrument or a guitar, a violin, but maybe you play something like, I don't know, a double bass, a stand-up bass, or a bass clarinet, anything that is sort of vertical. Or so what you can do is you can do your mount orientation as well. It's horizontal by default, but if you do a vertical mounting, then what you want to do is change this drop-down menu to vertical. And once you do that, notice how it starts the calibration process all over again, and just kind of trying to hold nice and still. And you'll notice that, you know, I'm not holding too still, but it'll be fine. And we'll wait for it to do its thing, and basically what it's going to do is it's going to behave exactly like its normal orientation, except it's going to, you know, make everything relative to its vertical. So now we got that. Leaning up goes up, leaning down goes down. It's rocking side to side. And so it's a really savvy way of making sure that, you know, however you need to mount this twist, that it is going to function the way that you most desire it to function. So thank you very much. That is everything you need to know about the twist, hopefully.